So now we're going to look at the inception of modern science in this period. And so I'm going to focus mostly on astronomy. There were other things going on in the world of sciences, it's true, but the astronomers are very interesting, for one, and also we see a kind of a sequence of astronomers who are beginning to make great advances in understanding the world. And moreover, most of these names are already going to be familiar to you anyway. So the first one we're going to talk about is Copernicus. His De Revolutionibus Orbium Celestium in 1543 was a kind of world-changing document. Now, this is really before the pre-stages before modern science. We think of Copernicus as being kind of the morning star of the scientific revolution. His name has almost apotheosized into a metaphor for revolutionary visions of the world as it truly is. For example, Kant will later speak of a Copernican revolution in epistemology that he has introduced. And so we almost look at Copernicus as a kind of a metaphor for these type of revolutionary shifts in how we understand the world. But Copernicus's views were one of the few epic milestones in transforming our worldview from ancient to modern. Now, who was Copernicus? He was a churchman, he was an ecclesiastical administrator who privately practiced astronomy. His theory was complete around 1510 and was published in 1543. So you see it took him some 30 years before he even published his ideas. Well, there were various reasons for being very careful at that time, and we will see that especially in the case with Galileo, who we will see in just a minute. But Copernicus was very careful about disseminating his ideas because, because it was so revolutionary. Now, Copernicus conceived of a heliocentric system as a more elegant model. Note that he's not truly a scientist because he did not derive his ideas from empirical observation, and it was only much later that the empirical observations confirmed, long after he had died, that confirmed his worldview, his idea of a heliocentric solar system. But there were many legitimate objections to Copernicus's model. For one of the key problems for Copernicus's model of the heliocentric system was that he thought that all of the orbits of the planets were perfectly circular. And this is in part because he so admired Plato. And for Plato, the circle was a perfect divine form. And because he assumed that all of the orbits must be perfectly circular, his system did not match up with reality, and therefore it lacked predictability. In other words, it lacked the ability to predict celestial events. But it was a more elegant system, and Copernicus believed that God would have created the world in a more elegant way than the old Ptolemaic system, which had a lot of epicycles in which the planets had to move around the Earth and the Sun as well. So that system was quite messy. His De Revolutionibus was not quite science. It was anti-Aristotelian, and it was anti-Ptolemaic, and so he's kind of the beginning of this quest to understand the way things really are in the world through scientific observation, but it's not quite science. The next person who completes a piece of this puzzle is Tycho Brahe, who lived from 1546 up to 1601. He is our nearest predecessor to the scientific revolution, a Danish astronomer. And after much observation, he concluded that Copernicus had to at least be partially correct. But he could not detect a parallax of stars needed to confirm the Earth's movement. So if the Earth is moving around the Sun, then it has to be a long way from the Sun. And so as it goes around, it would be in greatly differing positions as it went around, which meant that you would be able to see parallax in the stars. This kind of occurs when you move in a position and you can see the relativity of your position of other things as you move around. So they thought that, well, if Copernicus is correct and the Earth does go around the sun, then we should be able to observe the parallax of light coming in from distant stars. They didn't have any idea just how far those stars were away from us. And that's why they could not observe with the instrumentations they had then the parallax of the light coming in. So Tycho comes up with an alternative system. And his system basically held that the other planets revolve around the sun, but the sun revolves around the Earth. So you have the Earth is stationary, and the sun goes around the Earth, but all the other planets go around the sun. So this is kind of a hybrid system. And this one was favored by church authorities because it allowed the Earth to remain still. For some reason, the Roman Catholic authorities had determined that the Earth needed to stay still. It needed to be at the center of the cosmos. It needed to be not just the center of biological life in the cosmos, it needed to be the geographical, the cosmic center of everything. And so they had unnecessarily attached many theological ideas to the centrality of the Earth in the cosmos. So anyway, they favored Tycho's system. Now, Tycho did base his ideas on many empirical observations. Indeed, it was a major move towards modern science, but it will be his student, Johannes Kepler, who will discover the final key to the Copernican system. But one critical issue remained. What moved the planets? No one really understood what made the planets move and go around. God was creator. All of these men were theists and believed in God. But surely his creation could be understood, and they wanted to understand what it was that made the worlds move around. So this leads us to the next stage. So now let's take a look at Johannes Kepler. Lived from 1571 up to 1630. He was a mathematical genius, second only to Newton, whom he foreshadowed. Kepler's work is going to catapult science forward with his planetary research. This is a man who observed the movements of Mars for 7 years, every day, to track the movements of Mars. And through the tracking of Mars, he was able to discover that Copernicus was correct. The planets do move around the sun, including the Earth. However, he disproved Copernicus on one thing, and this was critical to making Copernicus's larger point correct. Copernicus believed in perfectly circular arguments. Kepler discovers that the orbits are indeed kind of elliptical, egg-shaped, as opposed to perfectly circular. And so once that was figured out, and it was figured out how fast they move at different periods in that elliptical orbit, then Kepler was able to show that indeed Copernicus was correct. And so, building on Tycho, Kepler abandoned the theory of the circular orbits and confirmed and mathematically explained Copernicus's theory. And it just took him decades of painstaking research to do this. He gives humanity the 3 laws of planetary mechanics with exquisite mathematical precision. And thus Kepler nailed the coffin on 2,000 years of Ptolemaic astronomy. Anything connected to Aristotle's philosophy began to wither away at this point. And so this turn to modern science and the whole turn in modernity is going to be essentially a turning away from Aristotle and scholasticism. Next, we look at Galileo Galilei, lived from 1564 up to 1642. Galileo in 1610 wrote a work called Sidereus Nuncius, the Starry Messenger. He had discovered how to build a telescope, and optics were a field of study at that time that he was much interested in, and he was able to put together the right lenses and build a 30-power telescope, which is powerful enough to reveal all kinds of stunning things about the world beyond our atmosphere. In fact, because he was the only one who had one at that time, the things that he had discovered were simply unbelievable to most people. It was almost a worldview-changing set of discoveries that he announced in this book, The Starry Messenger. And it got him in a lot of trouble as well. So he challenges people's worldview by these new revelations of things that he saw through his telescope, and he was ultimately censored by Rome. And he has a legendary struggle with the Roman Catholic Church. And he sets up an ongoing friction between religion and science that many feel like continues all the way down to this day. But the Roman Catholic Church was very slow to accept Copernicus's views and the discoveries of Galileo due to a lot of theological concerns that they have about the centrality of humanity and the centrality of the earth in God's creation. However, Galileo will leave an amazing legacy as a pioneer of observational science. I think we could say he truly was a scientist, as Kepler was. And so this is some of the beginning of this whole quest to understand the way the world is through observation. So his claims arise from empirical evidence, empirical observation, not conformity to authority. He doesn't begin with authoritative statements, say from Aristotle or the church or other sources like that, and then reasons from that. No, he insists on starting with what he saw with his new instrument, the telescope. And this is going to lead us to one of the central figures that we want to study today, and that's Francis Bacon. Francis Bacon in 1620 wrote a work called Novum Organum. This is a new organon, a new instrument. It's an attempt to lay out a project, a philosophy of science, and a new methodology for gaining knowledge about the physical world. Bacon's philosophy of science was not science itself. I don't think anyone would basically call Bacon a scientist. He didn't engage in scientific exploration, experimentation, and so forth and so on. But what he did do was to lay out a complete methodology and justify that methodology and give coming scientists a kind of framework from which to work. And so it's a groundbreaking work in many ways. It's a turning point toward an entirely new methodology. Basically, it's going to give us an inductive method versus the Aristotelian deductive method. Now, what is induction versus deduction? Well, induction, which is what Bacon is going to set forth, is basically looking at the world around us, gathering data, and once we have enough data, coming up with a kind of inference based upon that data. But that doesn't mean you stop looking for data. You continue to look for data, and then you update your inference based on that data as needed. And so the way I illustrate this sometimes to my students is, let's just suppose that I told you to go out and find a frugalich. And you're like, well, I don't know what a frugalich is. And so I tell you what a frugalich is, and then you go out and collect samples of it. And then you bring them into the classroom or the laboratory, and we analyze that. And then we come up with, maybe we have 100 samples, 100 data points. And then based on those 100 data points, we will make an inference about the nature of this creature or plant or whatever it might be, okay? But that doesn't mean you stop looking for samples. You continue. And at some point in the future, after you have 10,000 samples, you might need to update and revise your inference based upon all of that data. So it's data-driven. It's kind of from the ground up. Whereas Aristotle used a method that's more deductive. Now, Aristotle would begin, and he would use something quite effectively that was known as a syllogism. And the greatest example of syllogism that you've probably heard or even used is the one about Socrates. All men are mortal. Socrates is a man. Therefore, Socrates is mortal. Well, but the question that Bacon is starting to ask here, about Aristotelian deductive logic and deductive reasoning is this: how do you know those premises? And that's the problem. And so over the years, Aristotle had almost become like an encyclopedia or a dictionary in which one could look up information and then begin deductively from Aristotle, as if what Aristotle said was the gospel truth, and you could use that as a premise in your arguments. No need to go out and look at the world. Just start with what Aristotle said and reason from there, okay? And so it isn't that Bacon doesn't like Aristotle, he just doesn't like what Aristotle had become to the schoolmen, to the scholastics, and how they had used Aristotle as a kind of fact book in itself for using deductive reasoning. And so he wants a new instrument, a new organon. And so this new instrument is to go out into the world and begin to collect all kinds of samples of all kinds of things, make observations. So for example, that's what we see going on with these astronomers, is that they're making many, many observations, and then they're deriving their conclusions from their observations. So, the meaning of novum organum, a new instrument, decidedly and intentionally abandoning scholastics, abandoning the whole idea of universals and metaphysics. This is the gobbledygook of monks and mystics. And so the idea here is to get your hands dirty going out and looking at the world and analyzing it. If you want to understand things, you're going to have to go dig up bones. You're going to have to go dig through layers of the earth. You're going to have to go do a lot of experimentation in the laboratory. You're going to have to, in fact, Bacon looked at the entire world of learning and envisioned a giant university with many, many departments in which these tasks were divided up into different disciplines. And a whole army of investigators would go out into the world to investigate all these different areas of life. Bacon's induction is not yet a fully developed modern scientific methodology. It is a piece, it is an important key for doing modern science and having a modern scientific method, but it's not quite there. Induction alone is not the scientific method, but you still need it as a component in that method. So it does supply a key element. Modern scientific methodology requires that a guiding hypothesis be conceived, and then some type of experimentation or observations need to be made to verify the truth or the falsity of the hypothesis. You're trying to disprove the hypothesis. And so you make as many observations as you possibly can, or experiments to see if you can show that the hypothesis is incorrect. And so there's not one single methodology in science. There are many methodologies. Many different fields have different methodologies. For example, in medicine, the double-blind placebo-controlled studies are a very careful methodology. But you couldn't use that methodology in astronomy, for example, or physics, okay? So Bacon supplies a necessary piece. But this procedure needs to be repeatable. Any of these procedures need to be repeatable for a person to be able to claim that they have scientific knowledge. If you discover something, I need to be able to see the same thing on my own, with my own observations or my own experimentations. This is much harder than it sounds, and there are at least 10 different types of scientific methodology that exist in different fields of investigation today. Bacon will explain 4 ways that human knowledge progresses, and also how human knowledge has been stifled for almost 2,000 years. This is one of the more interesting parts of his work, Novum Organum, and we're going to take a look at that in more depth. It's the 4 idols. These 4 idols are 4 areas in which human beings have a propensity to stumble, and it's kept us ignorant for 2,000 years, and he's ready for knowledge to move on. He's ready for the whole project of science to move forward, and for science to bring about a great amount of progress. Now, progress in the sense of not just technological progress, but progress in all fields of knowledge. And so he feels like this is the only way forward, but we have to smash these four idols first. So he smashes them so that he can begin with a new and clean foundation to build the edifice of knowledge. The four idols are the idols of the tribe, the idols of the cave, the idols of the marketplace, and the idols of the theater. Now, what are the idols of the tribe? Well, the human race is a tribe, and he basically calls us one big tribe. And so we have a peculiar traits and weaknesses that hinder science just because of being the type of creature that a human being is. Now, one that he points to, he doesn't call it this, but this is what we call it today, is confirmation bias. And this is a big problem, and it's never going to really go away. You have to become aware of confirmation bias, and then as you become conscious of it, try to eliminate it from your own thinking. But we all labor under this confirmation bias. What does it basically mean? Confirmation bias occurs when I want my beliefs, my desires, my thoughts, if you will, or my culture or my customs to be confirmed. And so I will listen to things that confirm my ideas, and anything that doesn't confirm my ideas gets tuned out. I simply don't listen to it. And so you can see this going on all over the world today. So become aware of how you are biased against things that would not confirm your own beliefs. So illusions that human beings see things as they are is also part of this idol of the tribe. Human beings, we kind of get into this mindset that, hey, I see things the way they are. It's kind of this naive realism, and that things are the way I perceive them to be. And that is a kind of a default position for many human beings who are not self-critical or self-conscious of their thought patterns. Another one is that emotions drive intellect and reason. This is another idol of the tribe. And that is that our emotions are really what secretly drive and pull the strings behind our reasoning. So reasoning and intellectual thought and so forth is really a slave to the passions. And there again, we have to become aware of that and see how that's going on in our own thought. We also readily accept easy answers to very difficult questions because, well, it's hard to find answers to hard questions. And so we often want the easy way out, and we accept some kind of an easy answer. We shrug our shoulders and move on. We're too busy to find the hard answer to the hard question. And so we are lazy about persisting in investigation and in finding the true causes of things. So these are just natural propensities of a human being at pretty much anywhere on the planet. And so these things are holding us back. And these idols of the tribe are what need to be smashed before we can move forward with science. The next are the idols of the cave. The idols of the cave arise in the flaws of an individual's idiosyncratic thought patterns. Independent of my tribeness, the traits of human beings, I have my own private idiosyncratic hang-ups, if you will, that get in the way of science. Now, this is kind of reminiscent of Plato's cave analogy in Republic, Book 7. If you've ever read that book, I'm sure you've heard about the analogy of the cave. And so it seems as if Bacon is kind of like, building this idea on that. But the whole idea of the idol of the cave is that an individual undergoes influences that differ from others. I grew up in a different place, a different time than anyone else, and I've undergone different education, et cetera, speak a different language. All of these things go into making me a unique individual. So I have traits that I harbor all the way from birth. You also have those type of genetic traits that you inherit as well. And all of things are going to affect the way you see the world, and they're going to get in the way of you seeing the way things really are. Now, let me give you an example of this. I have a friend who is extremely colorblind, and she, up until her adulthood, until she was over 30, she had always seen the world as just sort of like black and white, if you can imagine that, a grayish, maybe just a slight little tinge of color, muted color, but there was entire colors that she never even saw, okay, like blue and green. And so, as it turns out, there's an invention that is quite magnificent. This is the new glasses that someone invented that a person can wear that corrects that problem. Now, let's compare her. She put those glasses on and suddenly she could see the world in color for the first time. It was, a magnificent transformation of the way a person sees the world. But now, compare this lady to another lady that I haven't met, but she's kind of like a supervision kind of artist lady. This lady is gifted in that genetically she received an extra set of cones and rods in her retina, so that she sees colors 100 times better than any normal human being. In other words, she can see 100 times more color than most people. And so she sees extremely subtle color variations, and no surprise that she would become an artist. But now compare these two ladies. One has supervision, and the other one is colorblind and sees the world in black and white. Now you can see here how this would be an example of how the idiosyncratic abilities or disabilities, if you will, of a person would affect the way they see the world. Okay, so these are idols of the cave. I have my own idiosyncratic hang-ups that prevent me from seeing things the way they really are. Science is supposed to get around that. And so if you're going to endeavor to be a scientist, you're going to have to find a way to get around your own hang-ups. So people fall in love, for example, also with a particular field of knowledge, and then invest heavily with energy and zeal into that field of knowledge. And so they tend to see the whole world as revolving around that field. I happen to know this. I'm a professor with a doctorate, and I know a lot of other professors who've invested extremely heavily into a certain field of knowledge. And so they tend to see the whole world as revolving around that field. After all, why else would you invest so much time and so much of your life and energy into a field unless you thought it was critically important? And so what happens is individuals in their own cave kind of privilege a certain area of knowledge as the hub around which all other knowledge spins. For example, humanists loved antiquity and exalted it. We saw that with, for example, Pico and Machiavelli and the other humanists of the Renaissance. And so they wanted to basically make the world revolve around ancient classical wisdom. Modernists will spurn this history and will exalt novelty. So some can't see the trees for the forest, and others can't see the forest for the trees. The next idol is the idol of the marketplace. And he says that this is the biggest problem of all, the biggest nuisance of all. The marketplace idols arise from the confusions of words, okay? Sloppy use of language creates many conundrums for science. It creates many conundrums for all humanity, actually, but it also gets in the way of science. We equivocate, we confuse terms, and we get tangled in semantics. And so some relish this kind of house of mirrors, and so sophists, for example, are some that do, and learn how to traffic in language games and word tricks and so forth and so on, and play word tricks and Jedi mind tricks, as I call them, on people. And so we have to learn how to use language responsibly and to use it more precisely. Now, this is going to anticipate some fields in the future that deal with human language and how to use it more precisely. The hard task of defining words must precede meaningful discourse in any field of knowledge. And if you've ever tried to define something that no one has defined before, you see just how difficult that can be. In the natural world, definition is quite hard. Definitions use words that also require other definitions. So Bacon recommends eliminating words for things that simply do not exist. And of course, he has his view that metaphysical entities do not exist, the universals do not exist. And so he wants to eliminate those terms. So imprecise language must be refined to describe things that do exist. And this is going to foreshadow by 300 years the school of analytic philosophy that seeks to create a very precise language to solve problems just by coming up with more careful language usage. The last idol is the theater. And in some ways, I think this one is the biggest idol of all. These idols come from the various systems of philosophy or theology or other dogmatic theory that we embrace. But he calls it the idol of the theater because it's kind of like a play. These systems of thought follow a script. And once you buy into a system that orders everything and defines everything for you, you can't really see things any other way. And so anything that comes along that's new, you work it into your system and you make it fit your system. But often you have to twist the facts to fit your system. So if you have a system of square pegs that don't fit into your system, or if you have square pegs that won't fit into your system of round holes, what do you have to do? You kind of have to round them off and make them fit into your round holes, okay? Einstein, I think, captured this one time when he joked that if the facts don't fit your theory, just change the facts. And so we see people doing that a lot today. We see people twisting facts to fit their narrative, twisting the facts to fit their system. And it isn't just in politics, it's in all kinds of areas of knowledge. People get wedded to a system, and they love the system because it helps them understand a certain quantity of things that are out there. But then they become so devoted to the system that they have to twist the facts to save the system. So Bacon is going to foreshadow postmodernity here a little bit with his insistence that worldviews and meta-narratives lock us into seeing things in a certain way. The postmodernists will, a lot of them at least, will generally hold to a constructivism, the idea that systems are constructions and systems are what help us to understand the way the world is. And so they fit things, whether it's philosophy or political systems and so forth and so on, religious belief systems, they're all constructed as a way to help us to understand what we see in those areas. Nietzsche will also say a good deal about this later on as well. Even Nietzsche's book, Twilight of the Idols, probably builds upon Bacon's exposition of the idols in Novum Organum. But unlike Nietzsche and unlike postmodernity, Bacon wants a way out of these problems, a true science to find actual truth. And so Aristotelian systems worshipped idols, and they don't root knowledge in experience. And so these are going to be some of the systems that Bacon is going to try to defeat. So Novum Organum is a fabulous work in that it lays out a kind of a new methodology, a new approach to understanding and learning that is going to try to get around all these idols and to build knowledge from the ground up using an inductive method.